Okay, students, Assalamu alaikum. We will meet again in this program of the numericals of the motion of the free falling body under the gravity. In the previous program, we have discussed about the kinematics or translatory motion, but here we discussed about the free falling body. Either the body threw from the earth towards a height or the body fall from a height. In both the cases, we have two things keep in our mind. In problem number 3.10, a stone is dropped from the top of a tower. Take 5 seconds to reach the ground. Calculate the height of the tower. When a body falls from a height, initial velocity is always become as 0 meter per second. Since the body comes towards the earth, therefore the acceleration is equals to acceleration due to gravity, which has the value 9.8 meter per second square at everywhere of the earth. But we take 10 meter per second square in these numerical, so we trying to make our calculation easy. Meter per second square. And time is to calculate over here. Time is 5 seconds given. Over here. And we find height of the tower. That means S, distance is changed into the height by using this. In this numerical, we use the formula to solve it. H is equals to VIT plus half GT square. In this situation, G is taken as positive because the body falls from a height. So we put the value in this. H is equals to 0 multiplied by 5. So time is 5 plus 1 upon 2 into the value of G is 10 and the value of time is square of the 5. So the height equals to 0 multiplied by any number come as 0. Therefore, we eliminate it. And then 1 upon 2 multiplied by 10 multiplied by 25. And now 2 1s are 2, 2 5s are 10. The height of the tower become as 125 meters. Again, I repeat this. The body is thrown, the body is fall from a height and reach to the ground in 5 seconds. But here the acceleration, we use the acceleration due to gravity. When a body moves free falling or under the gravity, A is always changed into the value of G. The actual value of G in all the places of the world is 9.8 meter per second square, but we trying to make our calculation easy, we take it 10. So we put the value in the formula. H is equals to VIT plus half AT square. Vi, the initial velocity, because the body falls from a height, Vi is always 0, multiply by time 5, 0 multiplied by 5 is 0. So in the next step, I will not take the 0 over here, but 1 upon 2 multiplied by 10 multiplied by square of 5, 25. Now 2 1s are 2, 2 5s are 10, and 25 5s are 125 meter is the height of the tower. Students, now come to the problem number 3.11. In this problem, a boy throws a ball with a velocity of 20 meter per second. That means the body moves from earth towards the height. It has the velocity, and this velocity must be equals to Vi. Vi is equals to 20 meter per second. But here the acceleration equals to minus g or minus 10 meter per second square, because the body moves away from the earth. And at a maximum height, when the body reach, the velocity becomes as 0. Vf is equals to 0 meter. Now we take Vf is equals to 0 meter per second. Now we find the time of the elapsed. That means we applying the formula over here. Vf is equals to Vi minus Gt. The Vf is equals to 0. Value of Vi is equals to 20 minus the value of G, we put 10, and time. Now 10t goes on the other side, it comes as positive. 10t is equals to 20, and time is equals to 20 divided by 10, it comes as 2 seconds. So the ball reaches at the maximum height during the time 2 seconds. But the question required the time of elapsed. That means the total time it takes to reach the upward direction, 2 seconds, and after the upward it comes downward with 2 seconds. The total time of elapsed is equals to 4 seconds. Answer. Start. Student, now come to the problem number 3.12. I hope all of you solve it very easy. It is the case of a body is thrown vertically upward. It is similar as 3.11. But I will solve the question 3.13. In 3.13, a stone is dropped from a height of the 40 meters. Okay, the 40 meters is the height whether the stone is dropped. That means initial velocity is equals to 0 meter per second. Since the body fell down, A is equals to G is equals to 10 meter per second square. In this numerical, the final velocity is required. At what speed the body comes to strike with the earth. So first, but the time is not given over here. Height is given. Height is equals to 40 meters. So we applying the first formula, equation number 2 of the equation of motion change into the gravity, and this formula is become as H is equals to VIT plus half GT square. But time is not given in the question and time is required. Height is 40. VI is 0 multiplied by T plus 1 upon 2 into 10 into T square. Now, 0 multiplied by any number of variable, it always comes 0. So we neglect it. But 2 ones are 2 and 2 fives are 10. But it comes as 40 is equals to 5T square. And now the T square is equals to 40 divided by 5. T square is equals to 8. And we take the square root over here. T square is equals to under root 8. Now the square root and square is cancelled. It comes as T square root of the 8 is 2.83 second. This is your answer. 2.83 is your answer, in which the body come and strike with the ground. But the second part of the question asking about at what speed the body come and strike with the ground. That means we find out the final velocity. And in the first part of the question, the initial velocity of the body, because it fell from a height, VI is 0. A is equals to the G taken as positive because the body come from a height towards the ground. A is equals to G. And time we calculate to reach the ground is 2.83. Therefore, we made another data. VI 0 meter per second. A is equals to G is equals to 10 meter per second square. VF required of the question, final velocity, and time we calculate 2.83 seconds. Now we are applying the formula over here for the final velocity. VF is equals to VI plus GT. VF we find over here, the value of VI is 0, the value of G is 10, and time is 2.83. We multiply these two numbers by each other, we obtain the final velocity by which the body strike with the ground is 28.3 meter per second. We will complete our kinematics and motion under the gravity chapters. I hope all of you understand very well, and remaining part which I leave, you do yourself and ask any question if you have any problem in these two parts of the chapters, kinematics.